When users report slow performance, the real cause often lies deep in the Oracle database. It might not be a single query, but a combination of procedures, dependencies, and execution plans that don't perform as expected. Visual Expert helps you identify and understand these bottlenecks by analyzing execution statistics and showing exactly where your Oracle code can be optimized. For this, Visual Expert includes performance optimization features. It collects and analyzes execution statistics from your database in production to identify the slowest objects. It can break down processes graphically to show which functions are consuming the most time. It detects code practices that degrade performance, like nested loops or complex joins, and can use AI to suggest optimizations for each identified issue. Finally, it finds missing indexes that slow down your SQL queries. Let's see how it works. Visual Expert includes a large number of rules to automatically check your code and detect various categories of issues. Some of these rules are specifically designed to improve performance. Let's take an example. This rule will identify SQL queries that include joins on too many tables, which will slow down the query response time. Here, we see that 7 instances of code have been found that do not comply with this rule. To learn more, we can open this page, which will list the objects that do not comply with the rule. To go a step further, we can examine in this view the query that violates the rule. Visual Expert will open its source code and highlight the cause of the problem, in this case, a join on 4 tables. And we can ask the AI to suggest a solution to improve this query. So here we see the initial query and a proposed solution. In the upper part, we see an explanation of the changes that were made and the reason for these changes. Below, the modified code is shown with the changes highlighted to make them more visible. The use of AI is optional. You can perfectly well manually correct the detected issues or use AI to save time by automatically generating potential solutions. After analyzing the content of your database, Visual Expert can identify missing indexes. By creating these indexes, you will speed up a number of queries that are currently too slow. These are particularly indexes on columns found in where, group by, having clauses, etc., like the columns we see here, for example. Visual Expert will list the missing indexes for one or more tables in your database. You can select one or more tables and request to see the missing indexes. Here we see that 3 columns in this table currently lack indexes, but they should be added. To verify the type of query using these columns, we can perform an impact analysis. For each one, for example here, we see that this procedure contains a cursor, which includes an SQL query with a group by clause referencing the name column of the product table. This column is among those recommended for index creation. Visual Expert can collect and analyze execution statistics generated in production by your database. This allows it to identify the slowest objects and suggest optimizations. So let's see how it works. For example, you can select procedures and request to see the slowest objects. The top 10 or 15 will appear and are sorted in descending order of average execution time based on the statistical data retrieved from the database. You can then select a procedure and break it down if it consists of multiple elements. For example, if it includes several SQL queries or different code blocks, this breakdown allows you to analyze more precisely the elements that consume the most time. Here we can see that there are 2 calls to procedures that are slow, as well as a particular SQL order. This SQL order could be optimized. We can do it manually. We can also ask Visual Expert's AI to analyze this SQL query and propose an optimization. It is then up to the developer to validate, accept, and copy this modification to apply it to their code, or not. Here we see the AI's proposal, which explains in the upper part the nature and purpose of the modifications, and then shows the modified code below, where we can see that joins have been replaced by inner joins. The modified part of the query is highlighted here, allowing developers to analyze the suggestion and decide whether to adopt it based on their criteria. This is a cross-sectional analysis of the application to identify the slowest objects. However, in other cases, we might focus on a specific feature rather than the entire application. Suppose users report that a particular feature is especially slow. We can start from the procedure that triggers this feature, knowing that subsequently, other functions call each other through a call graph. The challenge here is to identify within this call graph, especially if the feature consists of a large number of functions calling each other, which nodes are the slowest? Which of the called functions consume the most time? With Visual Expert, we can request to see the call graph corresponding to this feature, and for each element in the call graph, Visual Expert will add the information. Visually, we can see that the slowest element, which is causing the most delay in the feature, is this select statement. Otherwise, we would have had to analyze all the elements that make up this call graph. So we can focus solely on this select, either to optimize it manually or to request an optimization suggestion from Visual Expert's AI.